بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. النهارده هنتابع مراجعة عامة على مادة الجبر والهندسة الفراغية. طبعا مهمة جدا مادة الجبر والهندسة الفراغية لما فيها من دروس مهمة جدا. ما ننساش طبعا أهم الدروس اللي عندك اللي هي المصفوفات والمحددات. مهم جدا الهندسة الفراغية تعرفها عن 3 أبعاد، في علاقات مهمة جدا بين معادلة الخط المستقيم، معادلة المستوى، ازاي تحدد المستقيمين إذا كان هما متعامدين أو متوازيين عن استخدام القوانين اللي هي بتحدد التعامد والتوازي. Welcome my dear student in our math program for Science 3. Today we are taking new revision about algebra and solid geometry. My dear student, look at the first example. My dear student, if we have determined has order 3, 3. The first log 3 base 2, 3, 9, 0, log 5 base 3, 7, 0, 0, log x base 3 equals 4. Find the value of x. Look at my dear student, this determined its value product of the mean diagonal elements. We have multiplied log 3 base 2 times log 5 base 3 times log x base 3. Multi-choice. Choose the correct answer, 16, 32, 64 or 128. Look at my dear student, if we find the value of determined must be equals, look at zeros triangle, then the value of determined equal product of mean diagonal elements. Log 3 base 2 times log 5 base 3 times log x base 3 must be equal to 4. Then, my dear student, by using properties of log, logarithm properties log 3 over log 2 times log 5 over log 3 times log x over log 5 must be equal to 4. Right hand side from given equals 4. We simplify log 3 with log 3 and log 5 with log 5. We deduce that log x over log 2 equals 4. Then log x, my dear student, equals 4 log 2 or log 2 power 4 or log 4 base 2. My dear student, then x equals 16. Why? Because 2 power 4 equals 16. Then the correct answer, number 1, equals 16. Now we are translate, my dear student, to another example. Find the cofactor matrix of the matrix A 1, 2, 3, 2, 3, 2, 1, 2, 2. My dear student, look at the solution. C11 determined 3, 2, 2, 2 equals 2. C12 negative minor determined 2, 2, 1, 2 equals negative 2. C13 equals determined 2, 3, 1, 2 equals 1. What is the meaning of positive, negative, positive? Positive is the first is negative 1 for all power 1 plus 1. C11 we have first row, first column. We add 1 plus 1, 2. Negative 1 power 2 is positive. 1, 2 means the element in the first row, second column. Negative 1 for all 1 plus 2, 3. Negative 1 for all power 3 equal negative 1. C13 means negative 1 for all power 1 plus 3 equals negative 1 power 4 equals is positive. The first determinant is 2, second determinant negative 2, third determinant is 1. Then the element of the first row 2, negative 1, 1. By the same method, we find C21 and C22 and C23 equals equal to -1, 0. By the same method, C31, C32, C33, answer is -5, C31, 4, C32, -1, C33. We calculate C31 by using determinant 2 times 2, mean diagonal, 4 minus 3 times 3, 9, 4 minus 9 equals -5. 1 times 2, second determinant 2, minus 2 times 3 equals -6. 2 -6 equals -4 times -1 equals 4. Also, 1 times 3, 3, minus 2 times 2 equals 4, 3 minus 4 equals -1. Then we obtain the cofactor. My dear student, in the expansion of 3x squared plus 1 over x for all power 10, find T5, T9. Solution. Look at, my dear student, T5, 10, number n, C4, second power 4, first power 10 minus 4 is 6. T5, 10, C4. 1 over x second term for all power 4. First term 3x power 2 for all power 6. Then T5 equal 10 C4, x power -4, 3 power 6 and x power 12. We distribute power 6 among 3 and among the x power 2. Then by using calculator to find the coefficient of T5 equals 153,090. 10 C4 multiply 3 power 6. And by using summation of indices or power, x power -4 times x power 12 equal x power 8. This is T5. T9 by the same method, 10 C8, second power 8, first power 2. By the same method, by using calculator, coefficient of T9 is 405, x power -4. Another example. My dear student, now we are translate to another example. Prove that A, B, C are collinear if A vertex 1, 2, 3, B vertex 4, 0, 4, and C -2, 4, 2. Solution. My dear student, at the first, find A, B vector by using B minus A vector. We subtract B minus A, answer 3, -2, 1. Also by the same method, find BC vector equals C minus B vector equals -6, 4, -2. Then AB vector cross BZ vector to find the cross vector IJK. AB vector 3, -2, 1. BC vector -6, 4, -2. Calculate. This is cross AB cross multiplication BC equals 0. What do you mean? We deduce that A, B, and C are collinear. What do you mean, my dear student, collinear? Means 3 points are on same straight line. Then we deduce the rule. If we have A, B, and C, and the required, my dear student, prove that 3 points are collinear, we must prove that AB vector cross BC vector equals 0 vector. By using determine both IJK in the first row, Component of AB vector, second row, 3, negative 2, 1. Component of BC vector, negative 6, 4, negative 2 in third row. By using the first, look at I. If we delete I and minor determinant 3 times 4, negative 12 minus 12 equals 0. In J vector, we delete the first and first row, second column, 3 times negative 2, negative 6, 1 times negative 6, negative 6 equal 0. K, we delete the first row, third column, 3 times 4, 12, minus 12 equals 0 also. Then AB vector cross BC vector equals equals 0 vector. Then A, B, and C are collinear. Look at, my dear student, properties of multiplying vector by scalar. If we have a vector AX, AY, AZ, the vector A has 3 dimensions, AX, AY, AZ, belongs to R3. K belongs to R, or K belongs to real numbers. Then when multiply K by a vector equals K multiply AX, AY, AZ, we can distribute X, K about AX, AY, AZ equal KAX, KAY, KAZ belongs to R3. R3 means 3 dimensions. If we multiply 3 multiply vector 2, negative 1, 4, we distribute 3 times 2, 3 times negative 1, 3 times 4, answer is 6, negative 3, 12. Also, if we multiply negative 2 by vector 1, negative 3, negative 4, we distribute negative 1 among 1 equals negative 2, negative 2 times negative 3 equals 6, negative 2 times negative 4 equals 8. Now, we know that properties of multiplying vector by a real number. Look at, my dear student, if we have distribution property K multiply bracket contains a vector plus B vector, we distribute K among A and among B, K vector plus KB vector, or K plus L times A vector equals second property K plus L multiply a vector, we distribute K among L and L among A, K a vector plus L a vector. Associative property, we distribute XL a vector or LK a vector equals KL a vector. If we have a vector negative 1, 5, 2, B vector 4, negative 1, 3, then find 2A vector minus 3B vector. We know that 2A vector minus 3B vector, we multiply 2 vector among a vector each component and minus 3 times B vector for negative 1, 3. Answer is negative 2, 10, 4 minus 3 times 4, 12, 3 times negative 1, negative 3, 3 times 3 equals 9. Then negative 2 minus 12, negative 14, 10 minus 3, minus 3, positive 3 equals 13, 4, negative 9 equals negative 5. Now we are translate to another example. Find the vector C, which 2C vector plus 3A vector equals 2B vector. My dear student, we have equation left hand side 2C vector plus 3A vector, right hand side 2B vector. What is the required? Find the vector C, which 2C vector plus 3A vector equal 2B vector. As the first, we know that 2C vector plus 3A vector equal 2B vectors, then 2C vector equals 2B vector minus 3A vector. Then 2C vector 2 multiply B vector minus 3 multiply A vector. We find right hand side. Then 2C vector equal 8, negative 2, 6 plus 3, negative 15, negative 6. We add the first component with first component, second plus second, third plus third. 8, 3 equals 11, negative 2, negative 15, negative 17, 6 plus negative 6 equals 0. This is 2c vector. Multiplying by half or divided by 2 to find the c vector, 11 over 2 or half multiply 11, negative 17, 0. C vector equals 11 over 2, negative 17 over 2, and 0 vector. Quality of vector, the space. F vector equal ax, ay, az. B vector, bx, by, bz. Then we know that a vector equal b vector if and only if ax equal bx, ay equal by, z equal bz. Find the value of L, m, and n if a vector L minus 4, m square minus 3, and 1. B vector equals 5 and 1 n square. We know that a vector equal b vector. Then we deduce ax equal bx, L equals 9, and ay equal by. We deduce that m squared equals 4. Then m equals positive or negative 2. And az bz, then we deduce that n squared equals 1. The value of n equal positive or negative 1. The unit vector is a vector whose norm equals the unit length. What do you mean? A vector negative 3 over 13, 4 over 13, 12 over 13 is a unit vector or not? If we have square root of first power 2 plus second power 2 plus third power 2, if the norm of the length is 1, this is the unit vector. Then norm A, square root negative 3 over 13 for all power 2 plus 4 over 13 for all power 2 plus 12 over 13 for all power 2 equals 1. Then we must say a vector is unit vector. Fundamental unit vector ijk. We know that, my dear student, I represent x-axis, j in y-axis, z and k in z-axis. I vector 1, 0, 0, j vector 0, 1, 0, k vector 0, 0, 1. I vector 1, 0, 0, j vector 0, 1, 0, k vector 0, 0, 1. It is a directed segment whose straight point is the origin point and its norm is unit length equals 1. A vector 2i minus 3j plus k. The vector negative I negative 2j. Find 2a minus 3b. Norm ab, norm a plus b, norm a plus norm b. My dear student, 2a minus 3b, we multiply 2 multiply a vector, negative 3 multiply b vector, find the value of I, 7i plus 2k. A plus b vector, we add component I with I, j with j, k with k. Norm a plus b equals square root 1 squared plus negative 5 squared plus 1 squared. Answer is square root 27. Norm a plus norm b, find norm a at the first square root at the first 2 power 2, negative 3 power 2 plus 1 power 2, each component of a power 2 plus norm b, each component power 2 of b. Answer is square root 14 plus square root 5. We know that, my dear student, norm a plus b not equals norm a plus norm b. How to express directed line segment in space in terms or coordinate of its terminals? Look at, my dear student, OA vector plus AB vector equals OB vector. If we find, my dear student, OB vector, start from from O, origin point, OA plus AB, answer is OB vector. AB vector equals OB minus OA or B minus A. Example, A vector negative 2, 3, 1, B vector 4, 0, 2. Then a B vector equals B vector minus A vector by subtract the first minus the second vectors. Answer as 6, negative 3, 1. B A vector equal A vector minus B vector by the same method. Negative 2 minus 4 equal negative 6. 3 minus 0 equals 3. 1 negative 2 equals negative 1. We know that B A vector not equal AB vector, or AB vector equals negative BA vector. Unit vector in direction of given vector. If a vector AX, AY, AZ belongs to R3, then the unit vector in direction of the vector A and denoted by UA. UA means unit vector in direction vector A equal vector A over norm A vector. Example, A vector negative 2, 2, 1. Then unit vector in direction A equal vector A over norm A. Negative 2, 2, 1 over square root negative 2 power 2 plus 2 power 2 plus 1 power 2. Answer is negative 2, 2, 1 over 3 lengths of vector equal 3 equal negative 2/3 and 2/3 and 1/3. Now we are translate to another example. If we 135 degrees, 60 degrees, theta degrees are direction angles of the vector A. Find the value of theta. If the norm A vector equals 6, find A vector. This example is very important. Why? Because we know that cosine angle 135 cosine power 2 plus cosine power 2 theta x, cosine power 2 plus cosine power 2 theta y plus cosine power 2 theta z equals 1. Then we have angle 135 and 60, and the third angle is unknown. My dear student, look at the solution. If we have 135, 60 degrees theta are direction angles of the vector A, then cosine power 2 135 plus cosine power 2 60 plus cosine power 2 theta equals 1. Then by substitution, by using calculator, 1 over 2 plus 1 over 4 plus cosine power 2 theta equals 1. Then we know that cosine power 2 equals 1 minus summation of 1 over 2 plus quarter equals quarter. Then cosine theta equal positive or negative 1 over 2. Then cosine theta equals half, theta equals 60 degrees, or equals, if cosine theta equal negative 1 over 2, theta equals 120 degrees. Direction angles of the vector A are 135, 60 and 60, or 135, 60, 120. We have two direction angles of the vector A. The last angle theta is 60 or 120 degrees. My dear student, a vector 6 cosine 135i plus 6 cosine 60j plus 6 cosine 60j by using calculator equal negative 3 root 2i plus 3j plus 3k. Or, my dear student, a vector 6 cosine 135i plus 6 cosine 60j plus 6 cosine 120k. By using calculator, negative 3 root 2i plus 3j negative 3k. My dear student, now we are translate to another example. The opposite figure, my dear student, represent a vector A whose norm is 10 units. Express the vector A in algebraic form or Cartesian components. This number 1. Find the measure of direction angles of vector A. Resolve A into two components. The first in direction Z with magnitude AZ equals norm A cosine theta Z. This is norm A 10 cosine theta Z cosine 40 equals, by using calculator, 7.66. The second in xy plane, axy. Axy mean norm a vector sine theta z. Axy, component of axy plane, means component A sine theta z, equal 10 sine 40, 6.428 by using calculator. Now we solve the component axy in the two components of the first in direction of x with magnitude. Ax equal axy cosine 70, 6.428 cosine 70 equals 2.2. This Ax. The second in direction y with magnitude ay, axy sine 70 by using calculator, 6.428 sine 70, answer is 6.04. Cartesian form of the vector axi plus ayj plus azk. By substitution, about ax, ay, z, a vector 2.2i plus z 6.04j plus 7.66k. This Cartesian form of the vector A. My dear student, by the end of the lesson, we know that we have important rules in solid geometry. Take care, my dear student, before we solve multi-choice, think before solve the correct answer. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.